Feature Code Fest. How you doing? So, I'm Dylan, and I'm talking to you this afternoon about architecture, the stuff that is hard to change. Now, this is not real architecture, this is Lego architecture. This is easy to change. We're going to talk about something else. So, a little bit, who am I and what am I doing here? So, this is me, Dylan Beattie on Twitter and all kinds of other things. I'm CTO at Skills Matter in London, where I work with a team, build code, build platforms, organize conferences, all kinds of things. I run a .NET user group, the London .NET user group in London, and I'm a Microsoft MVP for Visual Studio and developer technologies. And I invented a programming language called Rockstar, which is fun if you want to waste a lot of time on silly languages. Я плохо говорю по-русски. I have been learning with a Duolingo. Does anyone know Duolingo? So I've been trying to learn to, speak a little bit of Russian because I come here quite a lot. And Duolingo teaches me some very strange sentences. So it has taught me how to do a «Кошка не нравится наша музыка». Проект зарождается, потому что архитектор все проспал. Этот код настолько стар, что уже нашел подводку. So I'm going to stick to English for the rest of the talk. So the title of this talk, Architecture, the stuff that's hard to change. Now, one of the amazing things about software is so easy to change. Software is this wonderful, exploratory, creative process. How many times a day do you go, I'll try this and see if it works? And if it doesn't work, Control Z, commit, revert, rebase, just check out master. We're very, very used to being able to try things and see if they work. But, that's not true of a lot of engineering. If you're doing construction, like on your house, you can't punch a hole through the wall and then go, wrong place. Control Z, try it here, bang, wrong place, Control Z. And so there is this point in software, lots of it, we can try things and see if they work. But sometimes the cost of those experiments can become expensive. We can't just try it anymore. If you're working in an organization where you're integrating your code with other people, if you try something, their code might break. If you have an API and you change something to see if it works, your customer's code might break. If you're, Amazon or AWS, if you provide a platform, you could break hundreds of other systems by changing something just to see if it works. And now increasingly aviation, healthcare, traffic, there are places where if the code doesn't work, you can really hurt people. And so there is this distinction. What I want to talk about today is code that is hard to change, code that is expensive to change, and how the idea of software architecture sort of plays into that. Now, no one really talked about software architecture until the 1990s, until, the same sort of generation as the World Wide Web and Visual Basic. So software architecture started off, this book came out in 1996. Mary Shaw and David Garland. And this is the first time software architecture really started getting people talking about it. Because to talk about this, we kind of need to understand where did it all come from. But I want to go back a little bit further, because there's an older thing, there's computer architecture, which people have talked about for a long time. And I want to look at this definition here. So this is a guy called Fred Brooks. Fred wrote, anyone read The Mythical Man Month about adding people to software projects? Very, very sort of famous engineer and author. And he worked with IBM on a system called the 360 in the 1970s. And he had this definition. Computer architecture, like other architecture, is the art of determining the needs of the user of a structure and then designing to meet those needs as effectively as possible within economic and technological constraints. I want to break that down a little bit, because there's three things that are important. Architecture, determining the needs of the user, designing to meet those needs, economic and technological constraints. So a lot of the stuff I'm talking about is things that I've learned being an architect. I started out as a developer, and then one day, we had some consultants working with us, and they said, we think you should be a systems architect. And I went back to my desk, and I was like, okay, this feels a lot like being a developer used to be. And so I started studying this idea of architecture. You know, what do architects actually do? How does it work? What are we responsible for? What can other people expect from us? And the first most important realization that I had is this: determining the needs of the user. Now, when you write code, you think of your users as users, the people who are clicking and dragging and filling out forms and everything. And so when you start thinking about architecture, you know, who are your users? Who are the people you are serving for? And it took me a while to realize that when you're the architect, your users are developers. They are the people building the systems that you are going to design. And it's not just the people who are already here. You need to design for people who aren't there yet. You're trying to design something that in 5 years or 10 years will allow these people to come in, join the organization, and be happy and productive and do good work. So you're designing a system for users who don't exist yet, to build products you haven't thought of yet, to sell to customers that you don't have yet. Easy, right? You're going to need a plan. Now, planning has got a bit of a bad reputation in software because there's been a sort of movement against planning in software development projects. Now, there is an old joke. This is René Descartes, he's a French philosopher. And Descartes is out one day and he's having dinner and he says to the waiter, "Could I get a cup of coffee without cream?" And the waiter goes to the kitchen and he comes back and he says, "I'm very sorry, sir. We have run out of cream. Would you like coffee without milk?" The reason why Descartes wrote about something called the illusion of choice. And we have this thing, the Agile Manifesto. And it says, Manifesto for Agile Software Development. We are uncovering ways of developing software, responding to change over following a plan. Now, the thing that the authors of the Agile Manifesto had seen was companies who would write a plan and then they would keep following it even when they knew it was wrong. That's the thing they were doing. But a lot of people read this and they go, brilliant, we don't need a plan. We'll just start writing some code and we'll fix it as we go. If you don't have a plan, it's not a choice. You're hacking with no clue what you're doing because that's all you can do. You need to have a plan. You need to be prepared to change the plan because things are going to emerge that you didn't know. But having a plan is vital for doing any kind of architecture because you at least need to have some idea how your system is going to evolve over 2, 3, 4, 5 years. There is another thing that has come out of the Agile Manifesto, which is this. The best architectures, requirements, and designs emerge from self-organizing teams. Now, what they mean by this is when a team clicks and they all start working together well and they produce good code and good systems and everything's great, let that happen. Don't go in and say, you're not allowed to do this. Don't stop it. But you can't rely on this happening. If your team comes to you and says, hey boss, we're stuck, we don't know what to do next, don't tell them, go and self-organize. Because they will self-organize across the street into the bar, and they will come back and be like, we self-organized, boss, it was great. And you'll be like, where's the code? They're like, oh no, we self-organized. We decided we weren't shipping anything. A lot of this stuff, if people come to you for help, you've got to have a plan. If you've got great teams and they know it won't happen very often, but have a plan, have some idea, be prepared to answer these kinds of questions from the people you're working with and supporting. So those are your users. Your users are developers. Your role as an architect is to help them, to give them guidance and support and help them build the right thing. Let's talk about economic and technological constraints. Here are the rules for software development. No hiring, no JavaScript, no open source, no Microsoft, no cookies. Somebody's going to be doing a lot of PHP. Whatever system you're working on, there are going to be constraints. There are going to be limitations on what you can do. And often, as an architect, you need to understand how all of these different things interact. Sometimes, the most valuable thing you can do is you can push back on one of those constraints. You can go back to the business and say, I don't think this is true anymore. This is the iPhone 1. It's released in 2008. Before this phone came out, everybody said that a touchscreen phone was impossible because touchscreens weren't good enough. And this was just accepted. You remember the old kiosks in the airport and the cash machines? And they weren't good. And everyone said, no one wants a touchscreen phone. And somebody at Apple was there the day they said, now is the time. The technology has just got good enough. It's time to challenge that constraint. We can build a touchscreen phone now. And this was one of half a dozen innovations that took place here. So as an architect, part of your role is being aware of those restrictions within your company. You know, you say, we want to hire 20 developers. The boss says, we don't have any money. There you go, economic constraint. Okay, let's turn it down. We're not going to be building a prototype smartphone because we don't have any people. We're going to build a mobile app instead, this kind of stuff. One of the other things that you're going to have to do as an architect is you're going to have to tell your team no. Because they're going to go to a conference like CodeFest, and they're going to come back and go, we want to do everything in this new shiny JavaScript framework, and you're going to be the one who says, We have a client who's still using Internet Explorer version 8. You can't do that. They're a big client. They make lots of money. And, you know, the team are going to be unhappy. And I'll talk later about how you can manage that. But those are the kind of three, guiding things: determining needs, meeting needs, looking at economic and technological constraints. So I'm going to give you now software architecture in 3 easy steps. This is how to be an architect. Make decisions, communicate decisions, reinforce decisions. Thank you very much. Bye-bye. So how do you make a decision? Because a lot of software, architecture and software at any level is about deciding what it is that you are going to do. So in order to make these kinds of decisions, there are 5 things that you need to understand. 1, what have you got? In any organization, there will be existing technology. And it's often tempting, when you join a new team or you start working on a new platform, the first thing you'll often do is you'll start looking at the code. And that's bad. 1, there is a lot of code. Reading code is hard. It takes a long time. You're not always going to get it right. What you're much better off doing, you want to understand, imagine, take a map of Europe. Forget about everything. Well, Europe and Asia, Forget about everything. Just look at the borders and what is crossing the borders. Where is the flow of traffic? What is the kind of information that is moving between these different systems? Let's take a really, really simple, so this is probably the simplest software architecture that exists. This is the internet, and we've got HTTP connections talking to a website. Now, as the architect, you don't care about the internet, and you don't really care what the website's doing. But this level here, you think HTTP, how hard can that be? Okay, is it HTTP or HTTPS? HTTPS, what strength is the certificate? When does it expire? How much traffic can we cope with? What's the capacity of this thing? Is it GET? Do we support put, post, delete? Are there APIs available on this? Do we support JSON over HTTP, or is this just HTML? What happens if we hit that with 100,000 requests per second? Is it going to scale? Can we put proxies and load balancers in there? You need at this point to channel, you're looking at all these existing systems and things. Don't care what anything was designed to do. Care about what it can do. Because you're always going to find a system where somebody says, oh, this is our high-performance user login system. You're like, it's not high performance. I've tested it. It crashes if we get 3 users at the same time. You need to understand what really exists. Now, lots of times, you'll be like, it's okay, we don't have to worry about that. We're building greenfield software, There's no such thing as greenfield software. There will be some things that already exist that you can use, or maybe some things that you can't use because politics and you're not allowed to touch it, and GDPR and legalities and stuff. There will probably be the failure of the last system they tried to build hanging around somewhere. There will be some politics. There will be stakeholders and business people who, for whatever reason, are going to try and interfere with your project. And there will be at least one black hole that your entire team is going to lose 2 weeks on something they thought would take a minute. You need to understand this landscape. Where are you building your software? There is no such thing as greenfield. You cannot just sit and make it up. Question 2, what do you need? Now, business stakeholders will come back and go, build us a website. It has to be fast and secure. And you go, okay. And you say to your team, we need to build a website that's fast. And your team go, oh, cool. I went to a conference. I learned all about Redis. Redis is really fast. And then the team goes away and they build a distributed Redis cluster. And a month later, the business comes back and goes, where's the new website? And they're like, oh, they're still making it fast. They're like, what do you mean making it fast? It's like, yeah, they're up to 20 million transactions per second. And the stakeholder says, what? It's like, you didn't tell us what fast meant. You just said make it fast. Have a conversation. Go back to them and say, all right, what do you mean by fast? How about if we can guarantee load time under 2.5 seconds for 90% of visitors? And the business person will go, is that fast? And you'll say, yeah, that's really fast. Trust me, I'm an architect. You know, because a lot of the time they don't understand. So translate it into, sit someone down and go, look, do some user experience testing. Try it out. 2 seconds, click, click. Click 3 seconds, 4 seconds. Once you get up to 10 seconds, you'll notice people are sort of looking at their phone, waiting for the pages to load. And that's where the business value of these kinds of things comes in. And sometimes they'll come back and go, that's too slow. Make it faster. And you can go back to them and you can go, well, actually, the page loads in 500 milliseconds, but then it takes 3 seconds to do all the JavaScript for the banner advertisements. Maybe we could take the advertising off if you want it to be faster. And then it becomes a business level conversation, you know. The other thing that I love talking about here is secure. The system has to be secure, you know. And you're like, who are we afraid of? What do you think, understand the threat profile. There are 3 classic security problems or threat profiles in technology. One of them is, someone's husband, wife, partner trying to get into their account because they've had a fight or they think they're cheating. This is quite hard because they've probably got their cell phone, they probably know their passwords, they know all kinds of things. So that's the one where you just need to make it easy for people to manage their own account and lock people out and revoke sessions. Second one here is, Chinese botnets. They're going to take 1 second to try and crack using some passwords that they downloaded on the dark web, and if they don't get in, they're going to move on to the next account. And the third one is Mossad, the Israeli intelligence. Don't worry about them, they're already in. Get on with your life, But understand that threat profile. If you've got the kind of site where, it's social media logins and stuff, say to them, well, how secure do you want us to be? What about if we just make the login take 3 seconds every time? Because people don't log in that often, and that'll get rid of the botnets. It'll stop them being a problem. But, security is a business decision as well as a technology decision. And as the architect, your job is to understand how secure, who are you worried about, and what are you going to do if you get attacked, Question 3, what can you build? How good is your team? How good is your process? Now, this one here, I just love this photograph, so I wanted to use it. It's a bit silly, but to me this boils down to 4 Ps. People, patterns, packages, and process. People. Who have you got? What are they good at? Who can you hire? What are the technologies in your organization that you're really strong on? Now, sometimes in IT, you'll get a thing where you've got a team who are really, really good with Java or .NET, and they're like, we want to use React on the new project. And part of your job is like, no, this is not an experiment, this is important. We're going to do this in trusted systems that we know well. If you want to learn React, we'll do it somewhere else, do it on a side project. Understand, people always want to learn new things. They want to try new technology, but there will be things where your people are really solid. Who can you hire? There is amazing technology out there, things like, Elixir and Scala and Clojure, which might work really well for a small team of 2 or 3 people. But if suddenly that becomes a big project and you go out and try and find 50 Elixir developers in Novosibirsk, any Elixir developers in the room? Yeah, you're going to have a hard time hiring people to run that. And this, again, is part business, but it's also a big influence on the technological decisions that you make about how to run your project. Patterns. Understanding patterns is a key part of architecture, but understand also some languages work very well with certain kinds of patterns. The best example of this, Ruby on Rails and the model view controller pattern and the active record pattern, those patterns are so heavily baked into Rails as a development framework. If you're using them, it's frictionless. It's so smooth. If you try and use Rails to do anything else, you are going to be fighting it the whole way down. So understand the natural alliances. Functional programming is very good at certain kinds of declarative things. Object-oriented programming is a good general purpose system. For lots of things, you can extend the basic capabilities of the platform by just plugging in packages, Node packages, JavaScript packages, NuGet packages. If you're using a popular platform, most of the things you're going to want to do, image processing, security, encryption, you can just install a package to do it for you. But that brings some dependencies with it. How much code are you now running that your team didn't write, that your team haven't audited, that you don't know what's going on with it? So again, there is this trade-off. Understand this is brilliant. We can go on NuGet and we can install packages to do just about anything, but now our code base is up to 850 megabytes and we haven't even written hello world yet. It's trade-off. And process is about how consistently your team can go, here's the idea, here's the stories, here's the code, here's the release. Round again. Stories, ideas, tickets, code, release. Round again. If you're tracking your team's velocity in something like Jira or Pivotal Tracker, look for the standard deviation of that velocity. How good is that team at saying, we'll have it done on Tuesday, and then on Tuesday they're like, yep, it's done. What's next? Because if there's variance in that, you need to take that into account when you decide what's your likelihood of success. What can you buy? Software as a service, platforms as a service, tooling. We love building things. You know, developers are creative people who enjoy, most of us anyway, sitting down and writing code to solve a problem. Now, there is a sort of mantra, a rule that I encourage a lot in software. There are some things money can't buy. For everything else, there's MasterCard. If you can buy it, you shouldn't build it, because somebody else is already selling it. You should be spending all of your time building things that you can't get anywhere else, because that's why your customers are coming to you. If they could get this stuff somewhere else, they'd go and buy it somewhere else, you know. And sometimes there are layers here. I use a system called Heroku. Anyone know Heroku? Heroku is hosting on top of Amazon Web Services. So Heroku takes AWS and they're like, well, we're not going to do data centers and everything, but we're going to do a really good build pipeline system on top of that platform. So we're going to add some value there. And then on top of that, we run our system. And then on top of our system, other people come and do what they need to do. Now, there is an interesting distinction here about at what point does something become part of your product. At the moment, my team and I are building a recommendation engine. So when you land on our page, it'll recommend, you know, videos and podcasts and things that are relevant to what you want to see, kind of like the way Netflix and Amazon Prime do. Now, all the data we're using is the same data that is in Google Analytics. So we had this big conversation, could we use analytics to build this? And I said, no, this is part of our product now. We want to own it. So we've built a system that tracks web traffic and analyzes it the way Google does. Because if you just want to look at your website and see who's using it, use Google. It's fine. It works really well. If that's becoming part of what you actually sell to your own customers, it's probably worth looking at building your own. And question 5, what can you lose? Raise your hand if there is a system in your organization that sends emails. Keep your hand raised if there are 2 systems that send emails. 3 systems? 4 systems? 5 systems? You ever see this thing where it's like there's a checkout that sends an email, and there's a user registration journey that sends an email, and there's a newsletter that sends an email, and you look at this, you're like, we're sending like 25 different emails. And all of them are being sent by using newmailmessage.send with an SMTP server or something. This is very, very common because people don't know. When the first person builds it, they're like, all right, I need to send an email. Bang, mail.send. Second person maybe doesn't know that that already exists, so they build another one. The third person doesn't know. The fourth person is like, well, there's 3 systems already. I should probably just build another one. And you just end up with all these systems, you know. And as an architect, you want to look for opportunities to rationalize this. Because how easy is it? Someone says, we've done a rebranding. We want all the email to be purple now. Big purple stripe at the top. That's cheap. That sounds like a really easy thing. Then you realize you have 20 different email systems you need to go and update. That cheap change is now really expensive. It's hard to change. It's suddenly turning an email purple has become an architecture problem. And you don't want that, because that's not where you should be spending your time. Okay. So you understand the landscape. You know what you're up against. You know your people, requirements, process, packages. Decide what to do. Now, it sounds silly. This is actually the easy part. Once you've done all that and you've worked in IT for a length of time and you have some experience, you generally just a right answer will kind of emerge. I'm not going to tell you how to decide what to do, because that's what you have to do. That's the expertise that you need. But this bit is normally easier than you think. And that's when we get on to the next bit. Communicating decisions. Now, the problem with communicating decisions, when you design a software system, you have all of these amazing ideas floating around in your head. In your head, you have this picture. It's a map. This is how the system works. It's amazing and it's brilliant. And you try and communicate it to your team by giving them a diagram. And they get this. Diagrams are not a good way of communicating software. Now, in construction engineering, we have blueprints, and you have elevation drawings, and you have side elevation drawings, and you have isometric sketch drawings. And sooner or later, you build a building, and you look at the building next to the drawing, and you go, yes, this looks right. This looks pretty good to me. Let's take a software diagram. Anyone understand what this is? Does anyone even know what language this diagram is written in? It's a thing called Jordan DeMarco notation. So there you go. This is a database or a file system, and this is a function. It's a function, and this is some kind of output. Could you build this? Let's add a little bit more detail to it, because often you see diagrams like this in books, and it's like, oh, it must be good. There's an architecture diagram. No. Start putting more words on. What are they? Okay, so now we understand what some of these code names mean. Excelsior is Mercutio and Norman, and we get silly names in software. You need to understand what they mean. And the next problem we have is we're using this notation. This is Jordan DeMarco notation. It's an industry standard that was set up in the 1970s. Does anyone here know what Jordan DeMarco notation means? A couple of us have probably studied it in university. It's not really a standard, and by using this notation, we can only draw 4 different kinds of component. We're severely restricted by what it is that we can do. So, let's rip up the notation and invent our own. Let's grab some clip art and some icons and all kinds of things. Now, one, I've included a key. So many architecture diagrams, they just assume that everyone knows what all these little symbols mean. And then you have a conversation where someone comes back and is like, but what are the little things like crow's feet? Is that a one-to-many relationship, or is that a message queue, or you honestly don't know? So add a key to it. If you're using little symbols like this, what does the cog mean? Okay, that's a Windows service. What is this thing here? That's a database. What are these different colored lines? Okay, so this is ADO.NET. This is a Samba file share over here. This thing here, this the box thing, I love that. I got that from RabbitMQ's documentation. I stole it. I use it in all the diagrams I do now. That says these 2 systems are connected by a message queue. We're starting now to get to a point where you can look at this and you can sort of understand, all right, I think I know how we could start coding this. Or I think I know my team could build this piece, and your team can build this piece, and this is software as a service, so we just need to pay the bill and get the credentials and everything. And we can go, a step further with all these things. Now, compare these 2. The one on the left looks like the examples in the textbooks, right? It's clean and it's minimalist and it's elegant. And it's basically useless because there's not enough detail on it to understand how to build a system. The one on the right is useful, but it's starting to look a little bit messy. There's a lot of clutter on there. Don't worry about it. This is a real architecture diagram of a real system that I drew as a kickoff for a project about 3 or 4 years ago. And, this thing started and it got bigger and bigger and bigger and bigger and bigger. Zoom in. I've got this key here where I've documented all the things, including the fact that this thing here, so we got HTTP and ADO and link to SQL and nhibernate and nservice bus, and then hideous VB cursor-based library. I literally said, there's something in our network. We know that it connects to databases. I don't know what it does. I don't know how it works. The network traffic is horrible, but it's there, and we have to acknowledge and document the fact that this thing exists. Put on things that are meaningful to people. I've got icons that our business stakeholders recognize. This is a picture of the actual books that got printed by one of the systems involved in this idea here. Little comments like maybe sync by pressing a big red button. Don't ever be afraid to just put loads and loads and loads of detail into these diagrams, because that will help people make sense of what it is that you're doing, and it will help you understand better the system that you've designed, which was perfect in your head. And then when you try to draw the diagram, you're like, maybe this isn't going to work. I want to say one more thing about architecture. Here are two architectural diagrams. Which one of these do you think is the hexagonal architecture? The one on the left. This is an architectural pattern. It's called ports and adapters. So all of your business logic lives in the middle here. And all of your logic does is it exposes interfaces, what we call ports, for everything. You want to get data out of a database? There is a port. You want to send an email? There is a port. If you want to send data to a message queue or another system, there is a port. And then all of these things, you plug in adapters around the outside of it. This became known as the hexagonal architecture because some of the early drawings, there were 6 of these ports. This thing here doesn't mean anything. It's nonsense that I made up for this talk. But, you know, we have all these names. We have the hexagonal architecture, the clean architecture, the onion architecture, the N-tier architecture. And it's so easy to just kind of nod and go, yeah, all right, we get it, we get it, we get it. Never be afraid to push back. If someone shows you a diagram or says, we're going to use the hexagonal architecture here, go, sorry, can you just explain so that I understand what do you mean? The classic one of this, someone comes up with an architectural diagram for something. Boxes and lines. No key, no illustration. Put your hand up, say, the boxes on your diagram. And the architect says yes. And you say, are they cardboard boxes or plastic boxes? And the architect goes, no, it's software. And you're like, oh, could you label it? And they'll be like, all right, I think I see the problem here. You know, this stuff is hard. Software is invisible stuff with millions of moving parts. Turning it into diagrams is really, really difficult. And a lot of the kind of, textbook stuff doesn't really help because it doesn't reflect the amount of detail we need. So, you understand your landscape. You've made your decision. You've come up with some notations and some diagrams and shared them with your team. They've all gone off to work. You've got 3 teams building systems and everyone's happy and everything. Reinforcing decisions. How do you know as an architect that those teams are building the right thing? And actually this boils down to 2 things. We have these two English words, validation and verification. Validation is, are we building the right thing? Are we solving the correct problem? Verification is, are we doing it properly? Validation, yes, we're building a smartphone. Verification, yeah, but our smartphone doesn't work. It's the right product, but the implementation on it is bad. Now, validation in architecture is hard because all you can do is kind of look back in 5 years and see whether your company's still operating or not. It's very, very difficult at an early stage to work out whether the architecture is right because business is always changing and stuff. But verification is easier, and there are things that we can do quite early on in projects to start understanding this. So let's go back to our example from construction. Here is the architecture diagram, and here is the finished system. And we can look at them side by side, and we can go, yep, that looks pretty good. It looks like they built what was specified here. We take our software diagram, and we go, okay, let's have a look at the software. How do you look at software? I know, Azure, dashboard. Okay, maybe this is the wrong view. Maybe TeamCity can show us. I know, Visual Studio, we'll look at the code. This is the design, and these are 3 different views of what has been built. None of them actually helps us because there's too much detail. With software, it is so difficult to kind of step back and look at the bigger picture and go, all right, I can see how this was done. I can see how all these bits fit together and stuff. So it goes back to this idea of looking at traffic. Now, when I first started doing architecture, I tried to do it using code review. I had 3 different teams, all writing code, and I was like, I'll check all the pull requests to make sure that the right things are happening. Don't do that. 1, you'll burn out. You're exhausted. You're knackered. You're trying to keep up with 15 different developers. Sooner or later, you're going to be like, hey, I reviewed your C# code and I don't know what it does. And the team's going to be like, dude, we don't use C# anymore. We're using Scala now. Now, the other problem with code review is you have a design session with one of your teams, and you're like, okay, we're going to use an identity map here. And everyone goes, okay, yeah. And you're like, you understand what an identity map is? And they go, yeah. And then you look at the code, and sure enough, customer repo has an identity map of customer injected into it. This is fine. And when you're tired and it's late at night and you're trying to review 50 pull requests before you go home, you're going to look at this and go, yeah, identity map, fine, done, whatever. It doesn't tell you anything. It just tells you that the people in the meeting thought identity map is important, and so they've used that label. This could be anything. This could send email, This could be a system that deletes files. We don't know. All we've got is this. It is like walking around a city at night and going, okay, luxury hotel. This looks like a nice place. It says luxury hotel on it. And then you wake up in the morning and you're like, all right, we shouldn't have trusted the labels. So what can you do to try and, reinforce and support your teams in getting the right thing? One of them is about alignment. You have people, you have teams, you have technology. Align the technology with the problems they're trying to solve. Don't use JavaScript for your backend and PHP for your front end. That's stupid. Do it the other way around. Put the people who are good with JavaScript on a front end team doing JavaScript problems, and put them where they can communicate with each other easily. Give them their own Slack channels, give them email, put them in the same office, hire people who speak the same language is often a good start when you're trying to get teams to click together. But you can also use this the other way around. There's a thing called Conway's Law, which is an observation about software. It says if you've got a bunch of people who are talking to each other all the time and they collaborate on software, they're going to create components which are tightly coupled, which have a lot of conversation between them. If you have teams who are decoupled, they're going to build decoupled components. So try this, It's like, well, we've got an Android dev team down here in Porto, we've got the front-end Angular team here, and our F# analytics team is going to be in Moscow. So these people are working on tightly coupled systems that work well, and so are these people, and so are these people, but the time difference and the geography difference and the cultural difference will show up in your software as boundaries and interfaces and bulkheads and things. It's called the inverse Conway maneuver, or domain architecture isomorphism. Something that I've always wanted to try, and may do one of these days, is to literally have like a back-end team who speak only Russian and a front-end team who speak only English, and find an architect who speaks both, and see what kind of interfaces you get if nobody can talk to each other without having to go via the architect layer. I mean, it might be a slightly bad experiment, but I think it would be interesting. The other thing that you can do once you've designed and identified these boundaries is you can work with the teams and say, right, this is what we're going to do. Here's the interface design. The back-end team who are doing your analytics, you're like, right, here is the tests that you're going to need to satisfy. The front-end team over here who are doing stuff, you're like, right, you're going to be pulling JSON. By the way, here's some fake JSON you can start working with. These teams can start working immediately as soon as the interface is designed. And what you as an architect are going to be interested in is when you replace the fake data and the specs with a real system, you just look at this piece in the middle. Look at the shape, the traffic, the JSON schemas, the payloads, how much traffic is flowing across that boundary. Now, one question that comes up a lot, should architects code? Yes, they should, otherwise you forget what it is like, but you should not be working on production systems that are shipping to customers because you have an unfair advantage, because you have the picture in your head and the rest of the team are working from a diagram. What you can do is work with those teams on monitoring, dashboards, build the metrics and things. So you say to them, right, you build your system, I don't care, F#, Scala, use whatever your team wants to use. I'm going to work with you today on just building an endpoint so I can monitor the volume of traffic and the log messages. One, you get to keep hands-on, you get to keep coding, you understand your deployment pipelines and things. Two, you get to pair with people. It's a good way of creating credibility and bonding with the developers on your teams. And you get your sort of high-level map of the running system and all the stuff that's going on with it. So one last thing that I want to say about the architectural role, which is quite often there will be decisions that make sense for the business that kind of suck for the developers. A business goes, we're going to integrate with Salesforce or Dynamics CRM. And what generally happens is the stuff that works is now not an IT development problem anymore. It just works. The marketing team are like, this is brilliant, we can send emails and everything. And the dev team, they just get the stuff that doesn't work dumped on them. You're like, we're going to integrate, we're not building our own SMTP anymore, we're going to use MailChimp for everything. And the dev team are like, oh, this kind of sucks. But as an architect, part of your job is to go to them and say, do you remember last year, every Tuesday morning, we'd get an urgent marketing email and we'd have to drop everything and send the email for them? And they'll go, yeah. And you're like, have you noticed we don't do that anymore? And the team will go, oh yeah, you know. It's like Tetris. When you get stuff right, it disappears. When you get stuff wrong, it builds up. And so part of your job as an architect is to look for the benefit of those decisions and communicate them back to your team. And I want to leave you with this. Good code. How to write good code. We don't know, you know. Architecture is like unit tests. It's like integration tests. It's like refactoring. Good code happens when smart people look at bad code and make it better. And to do that, we have to have the confidence to be able to make changes. Architecture is one way of giving you confidence and freedom. Unit tests are a way of giving you this confidence and freedom. Integration tests, platforms, type systems. All of this is about empowering the people on your teams to look at something and go, that doesn't look right. I wonder if I can make it better, and giving them a safe place to try it, making sure they're not going to break anything outside that system. Because really, good code is just what happens when good developers understand the problem, and you give them the freedom to do their best work. Are we taking questions, or do we go outside to the discussion zone?
Okay.
Hey, yeah.
Yeah, thank you for tomorrow's performance. My question is, there is the tasks, many of the teams do this when you have two products and you must somehow merge them with two different architects. Can you give some advices on how to, to start doing this, at least?
You make them have a drinking competition, and the winner becomes chief architect. It's difficult. You know, you have two systems. Say you have so the classic example that I've seen personally is ASP.NET Web Forms and ASP.NET MVC. And someone going, we need to merge these two systems. And, you know, sometimes you go back to the business, you're like, right, do you really want us to combine the code, or do you just want this to look like one website? And if they say just make it one website, then you're like, okay, can we isolate our branding and fonts and color schemes and things? If we put that in a reusable component, and then we run something like a varnish or a load balancer in front of them, we can have customers think it's one website, the requests go to two different code bases, and then the customer-facing bits are all unified in a single place. So you can normally identify elements of it where it makes sense to do that, but really, you know, if the architecture is fundamentally incompatible, then you're always going to have one system, you're basically going to have to pick all the pieces out and then throw the rest away. Because it's, you know, it's the stuff that's hard to change. That's what architecture is. If it's easy to change, it's just code. And so if you have two different architectures and only one of them is allowed to stay, yeah, there is not really an easy way to do that, but maybe the people are asking the wrong question. Maybe what they want is just one website, not one code base.
Thank you.
Okay.
Hello,
hey.
Thank you for your speech, and I have a question. What should I do in situation when I feel that in our product there are several maybe wrong architectural decisions, and maybe I want to change that things, but I'm afraid that I will destroy product which already in production, and so what should I do?
Yeah, I mean, that's another good question. What do you do if you're working on a system and you think the architecture is wrong and doesn't fit the problem, but you're afraid of the risk of changing it? And risk there is, you know, maybe you break something, or maybe you get fired, or maybe you break something and then you get fired. If you get fired and then break something, that's illegal. So, you know. But you can't do it without the support of the rest of the team. And one of the hardest things is sometimes you just realize that you're on the wrong team or you're in the wrong organization. But you go to them and you say, look, and you've got to communicate the benefits. You've got to be like, I think this is wrong because last week we changed an email to purple and it took 11 people 4 days to do it. That should be a simple job over here. And if you translate the inefficiencies of the wrong architecture into cost and risk, communicate that back to your stakeholders and go to them and say, I actually think if we do this work to improve it, we'll be cheaper, we'll be faster, we'll find it easier to hire people, these kinds of things. And if you're lucky, you work in a good place with smart people who understand, and they'll say yes. Sometimes they'll say, can we do it next year? Can we do it later? And make them sign something so you can go back to them and go, you said this year we could fix it. But it's difficult, It's making changes to architecture is not something you can just go home and fix overnight and ship it in the morning and get on with it. So, sorry, that's not a very helpful answer, but it's not a very easy problem.
Okay, thank you.
Hi.
We have one down the front.
Can you hear me? Yeah. Okay. Hi. Thanks
Hey.
for the speech. And I have virtual situation. Imagine that you come to the huge product, a lot of modules. It's complex, and to understand all this, there is no one who understands it. Yeah. And everyone expects you to become this person who is mastermind, who knows everything. Yeah? And what will you do? I mean, reading all this stuff and checking it, it's 5 months, and you need to be active already after some time.
So it takes longer than people think to get up to speed with it. The job that I do now, it took probably 6 months to get to a point where, and I don't understand the code base, but I kind of understand the structure of it, and now I understand what sort of monitoring tools we're going to need to be building to give us visibility on how everything's working. The best way of doing stuff like that, one, make sure people understand it's going to take a while. And when you're still early in that process, you'll do your best. And say, look, I think the module we need to change is over here. I'll have a look. Here's what we think might break if we get this wrong. It's going to take time, but use it as an opportunity, not just to study the code, but to build the kind of, dashboards and monitoring systems, analyze network traffic, put that stuff up where people can see it. Because one, that'll help you understand the code and the system better. It also creates tools which make it easier for the next people who come along. So that's a sort of good way to approach it.
But isn't it better to make some team of architects in this case if a system is too big? Or
the difficulty with the system's too big is until you understand the structure of the system, you don't know where to put the architects, if you like. So you have a big code base, and it looks like it's all very tightly coupled. What you want to do is to identify some boundaries. And so you can be like, okay, so that's the sales and financial system, right? We can get a team to start looking at that. And we understand the interface layer between that and the web front end. We'll get a team to start looking at that. And the back-end database system, we can get a team to start looking at that. But until you understand where those kind of divisions lie, it's very, very hard to know what to say to people. And you get good people and go, hey, self-organize. Maybe it'll work, but maybe not.
Okay, thank you.
Okay.
У нас есть еще время на один вопрос.
So thank you very much. I have one a follow-up question to one of the previous ones, and it's you say that architecture is an important thing and you have to do it right, but how do you know when you stop? I mean, in software you have unit testing, something that you can give it to QA and they will verify that it works as it's intended. But if it's software architecture, it's just exists, it's an imaginary thing, and how do you test it, how do you validate it?
So, as I mentioned, validating architecture is hard. And what you need to track is the cost of making changes to systems over a long period of time, months, possibly years. If the architecture is wrong, then simple changes will start to become expensive. But at that point, it might even be a little bit late. Because you're like, well, we've done it now and it doesn't work, but it's, like the other question was saying, it's going to be really risky to change it. But I mean, you get most people understand what good architecture looks like. If you've ever worked with a vendor who has an API, payment provider or an email service, anything else, there's the ones where it's easy for you because the documentation is good, the interface makes sense, they have a sandbox where you can test things. That's what good architecture should feel like as a developer. And there's the ones where you have to sign the XML using a rotating key and you get a 200 OK and you have to go and check the logs to see whether it failed or not. That's bad architecture, and that's what that feels like for a developer. And so one of the metrics for it, you go to the business and say, are we shipping the features you want? And then you go to the developers and say, do you like your job? Do you feel like you're doing good work here? And if the business are like, you're not shipping anything, and the developers are like, I hate my life and everything's awful, then, maybe it's architecture, maybe not. But good architecture without a good architecture and a good set of interfaces and standards, you're going to struggle very, very much to keep both of those things happening. But yeah, architecture is hard to validate because you can't do it in a week. You're building something, it's like putting up a building like a hotel, and you're like, it's amazing, and you come back after 3 months and everyone's unhappy, and you think, what did we do? And some buildings, 30, 40, 50 years, it takes to work out whether they really justified the cost of building them in the first place or not. So yeah, it takes time and it's difficult.